concentration of clay, all of those selenite crystals that form, in an aquatic environment. But still, there's some soil formation after Lake Jornada desiccated, so you're developing pathogenic carbonate. Something happened. There's a climate record that this pit's trying to tell us. And so you had a lot of this Eolian, wind blown, that's very similar to what we find today. So even without humans in the picture, something catastrophically happened here to cause this landscape to now be buried. And this is all, soil formation, typical soil formation here. And I wanted to say that, but then the roots, you look at the mesquite roots, they're just amazing, but these are the ones that we see. They typically stay above the caliche, the calcium carbonate, but not always. They go into it, and this holds water. It's like a sponge. And the black grama, surprisingly, in the 1950s drought, survived the drought where this was shallow to the land surface, where we had the tip, what we think of as deep soils. That's when they, were replaced by shrubs. That's the second thing I wanted to say. And then, of course, now you can see the buried land surface underneath that coppice dune, and the buried land, very subtle, but underneath that coppice dune and in the inner dune. But the last thing I wanted to say, and we were talking about this, how does all this calcium carbonate form? And the explanation that Sean has in the handout is from kind of the typical. It came about really because of the desert project. But people, the mappers, the scientists coming out from in the Midwest, Illinois, Indiana, Ohio, Nebraska, all of that, and you have all of this calcareous glacial till that comes down, the glaciers go back, the soil forms, it leaches out a lot of that, and so they'd get an acid bottle and put it, no effervescence, no effervescence, no effervescence, and then wherever it fizzed, they'd say, oh, well, that's the parent material. So whenever they came out here, which is what we call the sea horizon, if you look at the early descriptions, they describe all of this as sea horizon, C, and then the little C8 for calcium. But then it just didn't make sense. And so the only way to make sense of it is, no, this is soil formation. This is a B horizon. It's not a C horizon, it's a B horizon. And so they started putting the B. Then the other thing is, where's all that calcium carbonate come from? And is it in the parent material? Well, like if you go to the nature park, all of that, you look at all those rocks, they're not weathered. It doesn't appear that they're weathered. And then the groundwater, 200 feet down, okay? So they said it must be coming in from the atmosphere and dust, and we all know about dust, and it's a major component. But the dust traps, you look at the data, and yeah, the dust is calcareous, and it's all silt size pretty much, but 10% is calcium carbonate. So 90% are silicates, or words fell far. So the question is, okay, if all this is coming in by dust, and the dust is only 10% calcium carbonate, where's the other 90%? I mean, we should be looking at a loess cap. The word loess, L-O-E-S-S, it's silt deposits, Eolian silt deposits. There should be a loess cap, on all these soils. Where is it? Well, perhaps dust came, the calcium carbonate parachuted off, it got out, and then the silicates off to Oklahoma. There you go. But, you know, the only thing, calcium carbonate at a pH of around 8 is very insoluble. I mean, yeah, you put some acid on it, you lower the pH, it's very something. Up around it. So maybe there's more to it than that. Then enter the biology, the microbes, the plants. And one thing you can say is you take the biology out of a system, like in the Atacama Desert or the Taklamakan in China, you take the biology out, you don't get calcium carbonate. You can get gypsum, you can get sodium chlorides, and so you don't get calcium carbonate. So it looks like the plants are really involved in a couple of ways. One, they're pumping CO2 out, and you got to have CO2 in the soil to make bicarbonate to combine with calcium. And the second way they're involved is they're miners. You know, they're mining the nutrient wealth out of these particles. They're mining, you know, magnesium, potassium, all the nutrients, and they're mining calcium. So there's a net upward biological movement of calcium to the surface. And then they're pumping out CO2. And some microbes just seem to have a propensity at making calcium carbonate. When you look at, take this back to the electron microscope, calcified bacteria, calcified fungal hyphae, calcified root hairs. So yeah, there's a biological component to this. In addition, and we can't deny that atmospheric conditions is important. But the point is that there's a biological component that really hasn't made it into the textbooks.
So Curtis, you think that the major calcium source is here at the site? It's just from the parent material? Where does most of the calcium come from for the calcium carbonate?
I think that that if you do like the Franklin Mountains is a really good place. I mean, just taking, you know, Trans Mountain Highway across, and if you look at limestone juxtaposed on granite, and you look at the soils on the limestone and the soils on the granite, pedogenic carbonate on the limestone, no pedogenic carbonate on the granite. So, and the thing is, the limestone has a lot more calcium. Same thing with basalt. You look at a side-by-side comparison of basalt that has a lot of calcium and a sandstone that's primarily quartz, pedogenic carbonate on the basalt, right next to it, none. So
yeah, it's coming from the parent material.
Yeah. But there is
some dust, but
yeah, and calcium in rainwater. And if you look at the rainwater chemistry, I mean, there's a lot of calcium coming down in rainwater too. So those two sources.
I actually have another question. What stage is this this pedogenic carbonate here?
This is stage right here. Well, I'm so glad you brought it up. The Russians have developed this metaphor called soil memory. And so it's construction and destruction. Okay, so this would be a stage 4, but it remembers wetter climates. And the stage 4 are laminar layers, you know, these parallel layers. Okay, look at this. See these laminar layers? Yeah. They're remembering wetter time periods, and they're undergoing all this dissolution. And you see a lot of these dissolution, but you can imagine that laminar being pretty good shape if there hadn't been a wetter climate that started dissolving out the calcium carbonate. So
precipitating the downward maybe.
Yeah. Yep. I think so.
Through the cracks and crevices.
Yeah. And it doesn't appear to ever get acidic enough like if we put a drop of acid on this, that carbon goes off as gas. It doesn't appear to get acidic enough to release it as gas, only to turn into bicarbonate that could be moved deeper. That's right. Yeah. So a stage 4, that it has degraded.
What we're seeing here, where there appears to be an absence of carbonate in sort of this vertical column, and I know it happens at a fine scale, but also a broad scale. Could you touch on that a little bit?
Sure. The Crotovenus, I think, they're, had been mechanically burrowed. You got badgers and so forth that dig these big Crotovenus, but they're Crotovenus that have been here long enough that now they've developed new nodules in them. So that's my interpretation, Sean.
Now at the broader scale, getting into what's called the carbonate pipes, could you touch on that a little bit?
Yeah, the pipe is a dissolution feature. It's a concentrated zone of downward movement, but you can tell here there's a lot of clay in this. So at one time, and these pipes can go back as well. So, but at one time, this was a zone of concentrated water movement that would carry this and make this is a good argillic right here. I mean, this is the best. If you want to find clay films, clay skins, right there they are.
And then one more thing, because I've been asked about it, I think 3 times this week. There is sinkholes out here on the Jornada that the urban legends are that they're gypsum of what's caused them, and sometimes they're quite small, but can be
Pretty good size one.
Volkswagen bug size or larger.
I've never seen any that big.
I just don't know about the sinkholes, but for some reason it's come up when I've talked to people, including Connie recently, about those gypsum sinkholes. Do you know much about those? Mostly north of here, I think.
Mm-hmm.
Yeah. Well, again, karst topography. The water comes down, and we're talking, Kentucky, humid places where you have limestone. And they're out in Florida, and you have these sinkholes. It's called karst, K-A-R-S-T, topography. And but west of here, I mean, that's limestone. That thing I showed you, hitting it with a hammer. I mean, that's basically limestone. So you get that water come down, hitting that and moving across the top. And if there is a zone that funnels it down, then it gets amplified with time. And yeah, those, they can be pretty big. So I think hydrologically, it's where water's going down. Funnels down.
Always usually gypsum out here, probably what they're talking about.
Well, both. I mean, the gypsum for sure. You go to Roswell and you go to the the lakes and the Clearwater Lake, and I mean, there are some beautiful sinkholes in gypsum in eastern New Mexico.
What about the blue hole?
The blue hole.
Is that one? A
That's
gyp hole?
one. Yep.
Wow.
Yep. So you get that in gypsum for sure, but you also get it in carbonate.
Can you guys show us the gypsum crystals in here? With the shiny ones that are down there?
Yeah, that's real clear one.
When we're like scientists, we're like, so what about the shiny?
Look at the shiny.
So yeah, it's got
like those sparkly things.
perfect
like
cleavage.
sparkles.
You've already been saying.
Digest. Ungest.
I have a quick question. If you were saying that this site transitioned in the 90s, can we assume that these mesquite started growing around then? Like, how old do you think these shrubs are?
Bless you.
Yeah, and so one thing, mesquite is a native species, but typically it was riparian. I mean, it was along the arroyos and so forth. But the mesquite seed is very important food source out here. And the coyotes, if you ever look at coyote scat, man, they eat a lot of mesquite pods. But the rabbits eat them. But the cattle, it's honey mesquite. The cattle really liked the mesquite pods. And now you've introduced an agent of transport. So the cattle would eat the mesquite, they'd go across the landscape and poop, and there was a perfect, you know, with its own fertilizer and own water holding capacity, seed concentration. So that's the explanation why you've got mesquite all over this landscape. But a creosote bush is more of a, it appears to advance along the front, you know, where the mesquite, they penetrate enemy lines and pop up, you know, all over the place.
Is this area actively grazed right now? You guys know probably yes.
Connie and Ruth, there's still grazing experiments out here, right?
With the criollo,
My
right?